All right, now we'll go over to lab 3. Okay. That's why you can't do this one yet, but that's all right. In this lab, we will empirically deduce the runtime performance of certain functions. I need to edit that. Inside of the source.main BP, you'll see 5 functions, problem 1, 2, 3, 4, 5. For each function, empirically generate a performance graph via GNU plot. You haven't learned GNU plot yet, so you're not able to do this, but you're at least able to go in and inspect these problems and do a big O analysis, because your second part is to label what you believe is the theoretical big O of that function. You are able to do the second part. So you can go in and look at each of those problems and try and decide what the big O is. Hopefully you've got that. Place your documentation in a single PDF, text, or doc file. Okay, it actually will not work as a text file. You'll have to do PDF or doc. It's up to you how you do that. And that's you. Oh, look at that. It's a week and 2 more days. Man, I'm being so nice in these hours.
Generous.
So generous.
Oh, take it.
Ooh, don't know what that meant.
Punching stuff.
The wind is really blowing hard out there.
Okay, and we'll go into the source directory. Notice you go into main.cpp, problem 1, 2, 3, 4, 5. Problem 1, sum of 1, 2 squared enhanced. Problem 2, problem 3. Notice I'm making function calls. Problem 4, that should be easy to do the analysis of. Well, maybe not. Actually, problem 5, you can go and inspect these. Notice that I'm making a function call which may put code inside of that for loop. So that function is being called, in this example, a certain number of times. Make sure when here's your hint, that you look at the for loop, the heading of the for loop, before you finish your analysis. Because this one's going from 0 to 50, which is irrelevant to the number of n. Also, make sure you look at how many times I is being incremented. So it's being incremented 1 there, 1 there, 1 there. It's being multiplied by 2. So that's different than just incrementing by 1. So think about what multiplying by 2 is going to do. Your big hint is the tower of noise when I talked about dividing by 2. What do you think multiplying by 2 is going to do in a for loop? I'll give you a hint, it does not make it exponential. All right, any questions? Comments? Screams? Nope. All right. And you have some lab time, just under 50 minutes.